Difference between torque
Hold on. Yep.
and moment.
Say again.
Difference between torque and moment.
Actually, Cambridge is the only one that distinguish. Moment is just force and perpendicular distance. Whereas torque is applied to couple, moment of a couple. That means the two forces
Oh,
there. Torque is the force and perpendicular distance of a couple. Right? That means I have one take one force and perpendicular distance. And principal of moment, sum of clockwise moment equals sum of anti-clockwise moment about any point. Condition for equilibrium, no resultant force, no resultant torque. Right? All this must be in your head. Okay, let us try some question. This one, the whole question. The body is acted on by two forces, P and Q. A frictional force, F, holds the body in equilibrium. Which vector triangle could represent the relationship between the forces? Yep. What's the answer?
C.
Say again.
Either C or A.
Where got either one? Is whether you must be sure in the exam. Whether C or
C.
A. Right? The key is equilibrium.
C.
Equilibrium must be C. This one show that the P is
Oh,
resultant of
oh
A
yeah.
and B. Resultant of
I
P
didn't see
and
it.
F. This one Q is the resultant of P and F. This one F is the resultant of P and Q. So these are all must be in one direction, either clockwise or anti-clockwise. Okay.
Yeah.
How about this one? Which force system causes only motion of the beam without any linear motion?
B.
Donkey, is it?
Boy.
Boy. First step is to eliminate forces in the system in linear equilibrium. Right? Some of forces upward equals one of forces downwards. So this one, because see, you want which force system causes only rotation. You don't want linear movement. So this one got no linear movement. This one got linear movement. 6 going down, 8 going up. So got linear movement, cannot be answer.
Oh,
This one cannot be the answer. This one 7 downwards, 7 upwards there. So it's either this one or that one. A or D. This is C, this is D. Right? So for B or C, choose a point as pivot. Usually there is only one of the forces acting. Right? You want which force system cause rotational motion of the beam without linear movement. So don't have to worry about B and C anymore. B and C got resultant linear movement, B and C. So now work with A and D. Translation equilibrium, moment at P, moment at P. For A, sum of clockwise moment. Usually it's A or B only the answer. They won't force you, as I say, other board may force you to work through all of them and then choose the answer, but this is A or B only. moment about P, right? That's the point P. Anti-clockwise moment, anti-clockwise is 2 times x, 5 times 2x is 10x, and clockwise 4 times 3x, 12x, so it's in equilibrium. The answer is donkey, no? Okay, can work it out. Can take the point P, moment about P, no? Okay,
That means A is not moving, is it?
A is in equilibrium.
Oh,
Okay? You can try out if you want to for for D. Right? You can find 4 times x plus 3 times 3x. So it's 9. 9 plus 4 is 13. And this one is 5 times 2 is 10. So it's anti-clockwise moment, no? About P. Sorry. Somehow or other adjusting here and there. That is your P. Okay, now any more problem?
no.
Okay, let's try the next question. Try this one. Diagram shows a diving board held in position by two rods. X and Y are the two rods. Which additional force do this rod exert on the board when the diver of weight 600 Newton stands on the right hand end? Yep. Where is the direction of the force on the X? Direction of the force
Direction
on
of
X.
force?
Direction of force at X.
Five times. Wait.
It's downwards, right? This person is standing here. This lady is standing here. So this N is pushing up on X. So X is pushing downwards. So that's why you have downwards. Then Y,
Yeah.
right? The diving board is bearing on Y. That's why Y is pushing upwards. So how to solve? What's the answer? They are very kind for you already. They don't ask you to choose. They give you the answer up or down already. Now you have to find the value. That's all. What's the answer? Take moment about X or Y, no? Right? And take moment about X or Y to find the reaction force at either end, either place. Let the force at X and Y be P and P and T. Taking moment about X, right? Taking moment about X, so don't worry about P anymore. So sum of clockwise got some anti-clockwise moment. So clockwise, right? This one is given you. Right? Let me just remove it. Right? This 600. Clockwise 600 times sorry, all hidden out. Clockwise is 600 times 5. Anti-clockwise is this one going up. Anti-clockwise times 2. Okay. So T is what? 1500 Newton. And for equilibrium, for forces upward equals forces downwards. So sum of forces upward equals sum of forces downwards. Right? Right? T is upwards. Downwards is P and 600 from the lady. So P is 900. Answer is donkey. No? Can? Anything not clear?
Oh, yeah. Okay.
An isolated body can be, number 5, can be given a displacement, movement in any direction, or rotation. What is the result of applying a couple to a body? Yep.
Rotation.
Rotation only, no? Couple cause rotation only. How about this one? Diagram below shows a heavy flagpole, PQ, hinge at a vertical wall at NP, hinge at P, and held by wire connected between Q and Q, wire Q and point R on the wall. The weight of a flagpole is W, and the tension in the wire is T. What is the direction of the force exerted on the wall? What is the direction of the force exerted by the wall on the flagpole? How to solve the question? They are very kind to you already, lah. Give you all the answer already. Yep.
By the wall on the flagpole.
Direction of the force exerted by the wall on the flagpole. Three forces will pass through a point, no? Line of action will pass through a point. They are kind to you already. You can give you a line of action of this one, and line of action of T coincide at S. So the final force, reaction force must be along this line, no? PS, no? Yep.
All right.
How about this one? Pendulum bob is held stationary by horizontal force F, H. The three forces are acting on the bob are shown in the diagram. The tension in the string of the pendulum is T. The weight of the bob is W. Which statement is correct? Yep. What's the answer? Yep. What's the answer?
C. Answer is C.
Resolving vertically, T cos 30 equals W. Resolving horizontally, sine 30 equals to H. Usually they don't use tangent now. Tangent is just a sine divided by cosine. Or H equals to W sine 30. So answer is C. Okay,
Then W tan 30.
W equals T sine 30.
This I don't get it.
Hey, sorry. W equals to T cos 30. There.
Oh,
0. Yep. The
okay.
others are wrong. Usually they go to tangent now. Okay now.
Yeah.
How about this one? A ruler of length 0.3 meter is pivoted at the center. Right? That's the center pivot. Equal and opposite forces of magnitude 2 apply to the ends of the ruler. creating a couple as shown. What is the magnitude of the torque of the couple on the ruler when it is in the position shown? Yep. Answer?
So I don't know how to do.
Say again.
I don't know how to do this.
Force times perpendicular distance, that's all. One force times perpendicular distance. Right? That's the perpendicular distance. I've drawn for you the triangle. Right? This triangle. 0.3 meter.
Oh,
That's T, that's 50. The answer is C. Torque is force, one force, and perpendicular distance between the force. So it's 2 times right? 0.3. This one is 50 degrees. So further away must be sine, no? 0.3 sine 50. Okay or not?
yeah, okay.
How about this one? A uniform beam of weight 100 Newton is pivoted at P as shown. Weight of 10 Newton and 20 Newton are attached to the ends. The length of B is marked at 0.1 meter. At which point should a further weight of 20 Newton be attached to achieve equilibrium? Yep. That's the weight of the ruler, 100 Newton. And then 20 Newton. Let the distance be x. Taking moment about P. Right? There's your P. Sum of anti-clockwise equals sum of clockwise. Sum of anti-clockwise is 100. Right? Anti-clockwise 100. Right? Cause it go anti-clockwise times x. One division is x. Sorry, one division is 0.1. 100 times 0.1. Then 10, 0.1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6. 0.6. So you get 16. And clockwise is must be here lah. That your sorry, this is hidden up. Sorry. Right? Okay, clockwise is 20, 0.1, 0.2, 0.3, 0.4. Sorry, 0.1, 0.2, 0.3, 0.4. 0.4 times 20. Right? 0.4 times 20 is 8 only. So it's not enough. So that's why I choose here lor, to make it in equilibrium. Lor. Yeah. So can calculate your x. Lor. Answer is donkey. Lor. Can. Yep. Calculate anti-clockwise moment. Calculate clockwise moment and see where the other answer should be. Lor. 20 Newton should be placed. Yep. Anything not clear?
Yeah, can already.
Try this ladder one. Say they are very kind to you. They give you all the forces already. A uniform ladder rests against a vertical wall where there's negligible friction. If there's negligible friction, then this is normal reaction. No? Normal reaction. The bottom of the ladder rests on the rough ground where there's friction. So friction, there's friction there. The top of the ladder is a height h above the ground, and the foot of the ladder is a distance 2a from the wall. Diagram shows the forces acting on the ladder, which equation is formed by the moment. Right? So this is the normal reaction of the wall is equal to F. So what's the answer? This one is the normal reaction from the ground equals to the weight of the ladder. Taking moment about P, you choose, or you can take moment about Q, either P or Q. If you take the right place, then you will get straight answer straight away. Clockwise is this one, W times A. And then your F times H clockwise. Then anti-clockwise is W times 2A. Okay or not? Try this one. A hinge door is held closed in a horizontal position by a cable. That's your door. That's your cable. Three forces acting on the door: the weight of the door, the tension in the cable, and the force H at the hinge. They are very kind for you already. All you need to do is draw the line of action. Three forces must pass through a point. Draw the diagram for equilibrium. All the forces that pass through a point. Right? That's your T. That's your H. And then there's your W. Then you can see which is greater. Which least give the three forces in increasing order. So the smallest one is W. Next is HT. Okay. C.
Yep.
Okay, let's try structure question. Why I keep on giving you all the answer? Okay, say the two conditions for equilibrium.
No resultant torque.
There's
No
only one
resultant
condition.
force.
Sum of forces in any direction is zero, or no resultant force, no resultant moment.
Wait, teacher, can I say no resultant torque?
Better say moment. Torque is only reserved for couple. So sometimes you don't have couple. So it's better to say sum of moment about any point is zero, or no resultant moment about any point. Okay?
Right.
Three identical spring S1, S2, S3 are attached to a point A such that the angle between the two spring 120 degrees as shown in figure 3.1. The spring have extended elastically in the extension S1, S2 are X determined in terms of X, the extension of X3 such that the system is in equilibrium. Explain their working. Yep. What is the answer for S in terms of X? These two, X. This two is S cos 30. This one is also S cos 30. The two add together. They are pulling away. This one is pulling the other way. So 2S cos 60 equals to S3. Right? We resolve it in horizontal direction if we like. And then S3, SO, cos 30 is half. Therefore, the spring S3 has the same direction as SO. Yep, can.
Yeah.
The lid of a box is hinged along the edge X, as shown in figure 3.2. The lid is held open by a means of a horizontal cord attached to the edge F of the lid. The center of gravity of the lid is as point C, center of gravity. On figure, draw arrows, label W to represent the weight of the lid. Right? Weight act at the center of gravity. Right? Arrow, label T to represent the tension in the cord. Right? Cord is pulling to the left. Then an arrow, label R to represent the force of the hinge on the lid. So the three forces must pass through a point. Line of action of three forces must pass through a point. So produce it backwards. So the third force must pass through here. Okay? Can?
Yeah.
We may be cut off lah. Define moment of force. Yep. Define moment of force. All this must be in your head already.
Moment of force. It's like what's the distance, right?
Force and perpendicular distance of the force from the pivot. Okay now.
Oh, same as torque, right?
Roughly
Same as the
the same, but
definition
you
of
cannot
torque.
say same as torque. Torque is applied to couple only.
Oh, all right.
So the perpendicular distance is between the two forces. For torque, same force and perpendicular distance between the two forces. But moment of force is one force and perpendicular distance. State two conditions necessary for a body equilibrium. Yep.
No resultant force, no resultant
No resultant force
torque,
in any
no
direction.
resultant moment.
No resultant moment about any point. Two parallel string S1, S2 are attached to a disc. This is a disc of diameter cm as shown in figure 3.1. The disc is free to rotate about an axis. There's your axis here. Normal to its plane. The axis passes through the center of the disc. Right? They are very kind to you. They draw for you the force F. So the force in the tension in the string S2 is T, S1 is T. The level of length 30 cm is attached to a disc. When a force of F is applied at right angle to the lever, at the end, the three forces, equal forces, produce S1 and S2. The disc remains in equilibrium. On figure show the direction of of the force in each string that act on the disc. Okay, we have done that. Right? That's what we have done. There's a force there, 30 cm. For the force F of magnitude 150 Newton, determine the moment of the force F about the center of this. Anti-clockwise moment is 150 times 0.3. Okay or not? 45 Newton meter.
Can I see the diagram again?
That force and perpendicular distance. Change this one to meter is 0.3 times F. Okay or not?
Okay.
Right? F we are given. The torque of a couple produced by the forces in the string. What is the answer? Right? Torque equals anti-clockwise moment. No? Same. That's why we have calculate the value. The couple will produce a torque, and that is equal to the anti-clockwise moment. No? That we have just calculated. The force S1, torque equals moment of couple, force and perpendicular distance between the couple is 4.5 times right? Sorry, just to let you see the picture. Change this one to meter is 0.12.
Mm.
Okay, there's your clockwise couple, clockwise torque. This is anti-clockwise moment. Okay,
Yeah.
take the relation between force and momentum.
Um. Is it the definition of force?
Yeah, that's all. Force equals rate of change of momentum.
Oh, yeah.
A rigid bar of 460 grams is held horizontally by two support A, and B, shown in figure 3.1. The support A is 45 cm from the center of gravity C of the bar, and support B is 25 cm from C. Right? A ball of 400 grams falls vertically onto the bar such that the bar of the at the distance of 50 cm from C is shown in figure 3.1. The variation with time t of the velocity of the ball before, during, and after hitting is shown here. Right? Before hitting, this is where it hits. This after it hits. The time that the ball is in contact with the bar is shown in figure 3.2. This is figure 3.2. Determine the change in momentum. The change in momentum is final minus initial. Right? From the graph, mass final velocity minus initial velocity. Right? Mass is given. And final velocity is this one. No, read from here. Initial velocity is here. Right? Here I put it wrongly lah. It should be minus 0.4 minus 5.5. So you should get a negative answer. But as I say,
Alright.
examiner won't bother about the negative answer lah. Okay,
Yep.
to show the force
See
exerted
you on
by the
Thursday, teacher.
yep. What's the answer problem?
No. I mean, the class is ending already. See you on Thursday.
Oh, yeah, in less than 1 minute now. So you'll be finishing off anytime now. So you want a class on Thursday, is it?
Yeah.